Hi students, now we are going to solve question number 12 in the Cbse sample question paper. Now this question has a choice, either or questions are given. So this left side is one circuit type, okay. If you don't know means you can attempt this question. Any one of these two we are going to solve. Now the standard of this question is very high standard. So we have to work hard by solving similar type of problems. Okay, fine. You look at the circuit. In this circuit, are you able to see a 30-volt battery? Okay. It is in series with an ammeter, and there is a 6 ohm resistance. Then after that you can see here 3 resistors are in parallel. Is it not? What are the 3 resistors in parallel? 5 ohm, 10 ohm and one unknown resistance R1 ohm. So these 3 are in parallel. This parallel combination is in series with 2 more resistors, namely 6 ohm. Okay, so this entire bunch of 3 resistors we have to consider it as X. So the same equivalent circuit I am drawing here. I have drawn the equivalent circuit on the right hand side. So this bunch of 3 resistors now I am showing as X. So that 6 ohm and this bunch X ohm and this 6 ohm. These 3 are in series. So that here the current I ampere is flowing. Okay, I ampere is flowing in series. So this is the equivalent circuit. The conventional current starts from the positive of the battery. It flows through these resistors. So first we will find out the value of X and then we can find out the value of R1. You see here in the above circuit, if the current reading in the ammeter, is 2 ampere. 2 ampere current is flowing. Okay. Then what would be the value of R1 is the question. Actually, it is an interesting problem. I have drawn the equivalent circuit. Have you understood the equivalent circuit? So we can replace these 3 resistors by a single resistor whose value is X ohm. Okay. So the total resistance in the circuit is equal to this 6 ohm plus X ohm plus another 6 ohm. Okay, 12 plus X ohm is the total resistance. Okay, what is the applied potential difference? 30 volt, is it not? Then what is the current flowing in the circuit? What is the effective current or the net current? That is 2 ampere. That is a clue they have given. They have given the clue. So the potential difference, see here below this I can write V is equal to 30 volt and I is equal to 2 ampere. So R effective, the effective resistance is equal to V by I. So this is equal to 30 divided by 2. Therefore the effective resistance R effective is equal to 15 ohm. So this is the first step of understanding. So whenever you do the problem, you have to analyze the problem. Understand? So step by step approach is required. So what is the first step? We have reduced this bunch of resistance into a single resistance X and we have drawn the equivalent circuit. After that, the total, okay, the effective resistance in the circuit we have found, that is equal to V by I. Understand? Now this R effective, okay, this effective resistance is equal to 6 ohm plus X ohm. Is it not? That I am going to find out. So 6 ohm, this 6 is in series with X. So 6 plus X plus this 6 ohm is in series. Okay, this total resistance only is equal to what? 15 ohm. Okay, students. So 6 plus 6 is 12. So 12 plus X is equal to 15, or X is equal to 15 minus 12. Therefore, X is equal to 3. Understand? X is equal to 3. If you want unit also we can write. So the next step we have advanced. So first we determined the total effective resistance of the circuit, and that is the series combination of these two 6 ohm and this X ohm. So X must be what? 15 minus 12, that is 3 ohm. Understand? Okay, students, now how to find the value of R1? What is X actually? We have taken the parallel combination. The parallel combination of these three resistors only is what? X. Therefore, I will write 1 by X must be equal to, okay, 1 by X must be equal to this 1 by 5 plus 1 by 10, okay, plus 1 by 10 plus 1 by R1 plus 1 by R1. So this implies, okay, this implies 1 by R1, or another step we will write 1 by X is equal to, I am taking the LCM of these two, so that this is equal to 2 by 10. 1 by 5 can also be written as what? 2 by 10, is it not? 2 by 10 plus, I keep it as it is, 1 by 10 plus 1 by R1. So this implies 1 by X is equal to, now 2 by 10 plus 1 by 10 is how much? 3 by 10, okay, 3 by 10 plus 1 by R1. Now in place of 1 by X, we can write 1 by 3 also directly. So I can write here, instead of 1 by X, I am going to substitute 1 by 3. Here also I can substitute 1 by 3, okay. So 1 by 3 is equal to 3 by 10 plus 1 by R1. We need to find only the value of R1. So I written 1 by R1 on the left hand side. So 1 by R1 must be equal to what? This 1 by 3 minus 3 by 10. So 1 by R1 must be equal to 1 by 3 minus 3 by 10. 3 by 10 goes to the left side. Understand that? So this implies 1 by R1 is equal to, now what is the LCM of 3 and 10? 30. Okay. So I take the LCM. So this is a 30. So here 3 is there. 3 tens are 30. So the first numerator is 10 minus here 10 threes are 30. 10 threes are. So 3 threes are 9. 10 minus 9. I have taken the LCM on the right side. 1 by 3 minus 3 by 10 can also be written as what? 10 minus 9 by 30. So 1 by R1 is equal to 10 minus 9 is 1. So 1 by 30. So this implies R1 is equal to 30 ohm. Understand? R1 is equal to 30 ohm. Okay. Now you want to verify, means in this circuit this value you can verify. If you want to check, means you can verify that 1 by X is equal to, in this equation 1 by X is equal to 1 by 5 plus 1 by 15 plus 1 by R1. In this you can write 1 by 30. Understand? So that you will get X is equal to how much? 3 ohm. If you want, you can verify once again and see also. Okay children, I hope you must have understood the first sum, how to do this. And now we are going to the option. So R, choice. So there is a choice to this problem. The choice question is, another circuit is given. So this circuit consists of 4 resistors. The values of all the 4 resistors are given. You see, R1 is equal to 7 ohm and R2 is equal to 10 ohm and R3 is equal to 6 ohm. R4 is equal to 4 ohm. Understand? Now you can see that this 6 ohm resistor and this 4 ohm resistor, these two are in series. These two resistors are in series. So 6 plus 4 is equal to how much? 10 ohm. Understand? So if you want to draw the equivalent circuit for this, so R3 series R4, R3 in series, okay, R3 in series with the R4. So that is equal to 6 plus 4 equal to 10 ohm. That is the first step. But that 10 ohm, okay, that 10 ohm is parallel to another 10 ohm. So this is 10 ohm. 6 plus 4 is 10. Already there is one 10. So these two are in parallel. Understand? These two are in parallel. And this is 7 ohm. Understand? so that now the circuit gets reduced. So here 10 ohm parallel 10 ohm parallel 10 ohm implies that is equal to what? 10 and 10 are in parallel. 1 by 10 plus 1 by 10, is it not? Is equal to 2 by 10. So that is equal to again 1 by 5. So the effective resistance must give what? 5 ohm. 5 ohm. Understand? So here this parallel combination, the resistance is equal to what? 10 into 10 divided by 10 plus 10. So this is equal to 10 into 10, 100, 100 by 20. So this is equal to 5 ohm. So we can replace these two 10 ohm resistance by what? 5 ohm. 5 ohm. Understand? So if this is the battery, it is also given what? 20 volt. So this instead of these two resistors of 10 ohm, I can replace it by 5 ohm. So the circuit now reduces again. You can see this is a 7 ohm and this is a 5 ohm. So this 7 ohm resistor and a 5 ohm resistor, these two are in series. These two are in series. And this is what? 20 volt. So again the equivalent circuit. The equivalent circuit is what? This is a battery and this is a single resistor of 7 plus 5. They are in series. 7 plus 5 is what? 12. So this is 12 ohm. And this is a 24 volt, I think. Here it is given as a 24 volt. I should take the correct value. It is not 20. It is given as 24 volt. Okay. And easy numbers only. Easy numbers. Okay. So the total resistance is now 7 plus 5 is 12 ohm. The total potential difference is 24 volt. So what is asked here? Calculate the total resistance and find the total current in the circuit. So the I effective is equal to I total and this is equal to V by R effective. So this is equal to 24 divided by 12 and that is equal to 2 ampere. Okay, so what is the R effective? R effective is equal to 12 ohm. Okay, R effective is equal to 12 ohm and I effective is equal to 2 ampere. So it's comparatively easier than the first sum. I feel like that because for the students of 10th standard level, this would be better choice than the first one. Because in the first one, the steps are more than the choice question. So my dear students, how we did the first problem is this bunch of parallel resistors we replaced by a single resistor as X ohm. Then the 6 X and 6 ohm are in series. So we found the total resistance, okay, the total resistance in this bunch. So the value of X we determined. Afterwards, now we have found the that is value of R1. Similarly, here in the second sum, now what is asked is the effective resistance totally. For that, we reduce the 6 and 4 in series as 10. 10 and 10 parallel will give you 5 ohm. 5 ohm in series with the 7 will give you 12 ohm. So the effective resistance is 12 ohm. See, once you practice such problems in competitive exams and all, you need not solve and find. Quickly, by looking at the circuit itself, you can tell the answer. Such a practice is required. So the effective resistance we found, okay, that is the 12 ohm and it is 24 volt divided by 12 ohm is the effective current, that is equal to 2 ampere. I hope you must have understood well. Fine.